classes. Now, the last video I went from the transition matrix to the transition matrix to the transition diagram and then the other direction here. I personally find it easier to identify the classes looking at a diagram than I do looking at the matrix. It can be done either way, but we'll do it with the diagram. So I'm going to look first for absorbing states. So I know that in this case, this is going to be a class 2 by itself because it's an absorbing state. Now I'm going to look at the rest of my states and say, okay, well, 0 communicates with 1, 1 communicates with 3, 3 communicates with 0. Because you can get from any of these to any of the other of these, they communicate. Therefore, they are a class. So that's my other class. This class, transient, and that one is recurrent and also absorbing. This class appears to be aperiodic because you can get from 1 to itself, 3 to itself. You can get from 0, let's say, back to itself, either going 0 to 1 to 0, which is 2 transitions, or 0 to 1, 3 to 0. So it would be 1, 2, or 1, 2, 3. So you can do it in 2 or in 3. Greatest common divisor of that is only 1, so it's still aperiodic. So this one is going to be aperiodic. Absorbing states have to be aperiodic because you can always get back within one transition. So that's this guy. So my classes are going to be 0, 1, 3, and this is going to be my transient class. And then I'm going to have 2 by itself. That's the absorbing class. All of it's aperiodic. Over here, on this side, again, I have state 2 as an absorbing state, which makes it a class by itself. And again, these all communicate. And again, they're aperiodic. So that was actually not intentional, but they're almost exactly the same. And it turns out, these arcs are different, but it turns out this is also a class, 0, 1, and 3. And it's also transient, and that one's recurrent because absorbing states are recurrent, or absorbing classes and states are recurrent, and anything else that dumps into that absorbing state is going to be transient. Now let's say that we change this so that the probability of 2 returning itself, let's make that 0.5. And now let's say the probability of 2 going to 1 is 0.2. Probability of 2 going to 3 is 0.3. So now our matrix is going to be a little bit different. So we said I'm going from 2 to 1 is 0.2. 2 to 3, 0.3. Okay, so we have different matrix and also different classes because now you can get from any state to any other state now, right? You can go from, say, 0 to 2, 0 to 1, 0 to 3, 1 to 2, 1 to 0, 1 to 3, 2 to 3, 2 to 1, 2 to 0, and from 3 to 0 to 1 or to 2. So they all communicate. There are no absorbing states, and they are all recurrent. Now, are they periodic? The answer is going to be no, because 3 of them have a period of 1. They return to themselves. So the entire thing is recurrent. All the states are recurrent. It is aperiodic, and it's only one class, which means it is irreducible. Therefore, this guy is ergodic.